There we go. Cool. All right, so here's the first one. Now, I am a math teacher, so I am evil. So if you don't put the key, you will lose points. I mean, that's, like I said, it's incomplete if you don't put the key. The book doesn't make a big deal out of the key, but the book isn't the end-all, be-all, so there you go. This one, now, I was telling somebody asked me about this one, and I said, I expect most people will do this, but you don't have to. It's kind of understood. If you do this, what you're doing, let me see if you guys understand. Why do you think I asked you to do this data this way? Looking at the data. How many stems does it have just naturally, just to do it the way we did from the first time we did it? How many stems would it have? Just 4 and 5. And they would be about the same length. Does it really have good enough resolution? Does it really show you how things are distributed? So this is an option to do if you don't have that many stems. Not stems. You just break it up, not 4.0 to 4.9, you break it up 4.0 to 4.4, 4.5 to 4.9. So just listing it like this implies that that's what you're doing. So if you didn't do this, you're fine. If you put 4.0 to 4.4, now you know you can do this instead. Cool. You might never have to do this in this class for homework or quiz or whatever. I just want you to know that this is an option. So now you start, now you start. One thing we'll do today is we'll give you calculators if you need to borrow one. And I'm going to show you how to sort data, because that's really useful. Sort data in the calculator. But let me see. Can you guys help me out? Let's see. There's 4.0. What else is there? 2 4.0s. 1.42. Okay. And let's see. 4.0, 4.0, 4.2. Let's see. There's 4.5. 2 4.5s, I like it. 4.6.
What does that do in the next one?
Oh yeah, thank you. I forgot what I was doing. 5, 5, 6. Thank you. 8. Where am I at? 8. You saw 2 8s.
2 8s.
There it is. 8. Well, not there, Jeff. You can do it. 8, 8. 9. Cool. How's that look?
We're done with that.
Yay! And then 5, 5.0. There's at least one 5.0. Another 5.0. 5.1. 5.1. I like it. Thank you. 1.52. It looks like. And then a 5.3. 5.3. This is exciting. And then a 5.4. 5.4. Is that true? 3 of them? Oh, way over there. Okay. And then a 5.5 and a 5.7. 5.8. Oh, thank you. 5.5, 5.7, 5.8, and I think that's it. All right. Whew. Now, what would your key look like for this? I love it. Kick ass. Don't put commas, decimals in here. You want this as clean as it could be. So it's just purely showing you how it's distributed. And now I can see much better. It looks like the early 50s has, get rid of that, the most people in it, or the most things. I like it. Kick ass. All right, this one's not too evil. How many empty classes are there, by the way? 2. All right, then, so there's not just 4 classes. How many consumers were surveyed, knowing this is 11? 20. So you just add up the frequency. Frequency just represents how frequently somebody showed up between these ranges, right? Say again. Oh, how many people showed up in the first bar? 11. Second bar? 6. 17 so far. And then there's 3 down here. So 20 altogether. I love it. So that frequency bar has got to add up to be the size of your sample. Because the frequency bar represents how many things in your sample occurred between these 2 numbers, in this case. Between these 2 weeks. I like it. Here, these are probably guys. How many classes are there? 6, because there's 2 of them that are empty. Well, there's still 6 classes. And what's the class width? I mean, what's your gut just tell you? What's the class width? 20. I love it. Each class is 20 wide. And then for what percentage of the sample does the bottle shampoo last? At least 40 weeks. So how many does it last at least 40 weeks? Yeah, 3 of them out of 20. And that was a percentage we did on that thing last time. 15%, kick ass. I like it. Okay, cool. Not too bad, right? Pretty easy. Everything I asked you about here is going to be something we have to worry about in constructing this. Let's talk about how to construct these things. I like it. So everybody got what they want from this here? Everybody got that? Okay, I'm going to lay this to rest for a minute. Let me see you guys. Hey, I see you guys. All right. So let me ask you something that sounds as if it has nothing to do with what we're about to do. But it totally does. If I wanted to, this is an interesting room. It's got these panels already here. So let's say I wanted to redo this side and I wanted to put wood paneling on top of this. Just because. And let's say this is, let's say this is 35 feet in length. You guys got it with me? In my head, I laid down 6 foot tall dudes and gave an estimate. Is everybody with me? This is physical, but this is exactly the math we're going to have to do in a minute. So everybody understand what I'm about? I want to put wood planks down on this wall and cover it with wood planks. So it's 35 feet long. If I want to use 5 planks, how wide should each plank be? Yeah, of course, right? What'd you do? From 0 to 35. So I saw how the range that I want to cover is 35 feet. And then divided by the number of rectangles that I wanted to use, right? So it sounds very much like that shampoo problem. They had rectangles and they had a range they had to cover. So if I had, so let me make some data up. So let's say we got, let's see if this works. Okay. All right, we can do it. Sure, I like it. Can you guys see that? It's probably not the best choice of color. Nobody's complaining, so okay. So how, let me just ask you, what's your gut tell you, what's the range of this data? How far does this data range? What would you think to do? Subtract, yeah. It goes from what to what? 1132. So the range is 32 minus 11. I like it. So range in general is high minus low. So the range of this is 21. That's like the 35 feet for that wall. I like it. And really, if you think about it, the reason that this can be looked at physically is because I am trying to cover the range of data with these rectangles. So it is exactly like trying to cover a wall with planes. Now the difference is, let's say the next step, of course, is how many classes, how many rectangles. So the rectangles are called classes. So 0 to 20 was a class, 20 to 40 was a class on that shampoo problem. So the number of classes for this course can be 5 to 10. It's kind of convention. When do you think you would use more classes versus less? If I had 15 data points, I probably would not use 10 classes. So the bigger your sample is, the more classes you're going to want to use. So guess what? For us, we're going to use 5 or 6 most of the time. Because I'm not going to give you 800 data points to do by hand. I'm just not going to, right? You guys kind of with me? So if you use 4 classes, that sucks. You're going to lose points. Because you're not allowed to use 5 to 10. So let's say we want to use, what do you guys want to use? How many classes? 6. I love it. Kick-ass. So let's use 6 classes. That's just like me saying I wanted to use, what did I say, 7, or was it 5? 5 planks. Same idea. How many rectangles do you want to show up on your picture? You want to have 6 show up. Kick-ass. So how do we figure out how wide each rectangle has to be so that it covers all the data? Same thing I had to do here. What do I do to figure out? What did we do? At 35 feet to go, I wanted to use, I think it was 5 planks. I can't remember. So what did you do? You took 35 divided by 7 to see how wide each plank had to be. So what do I do here? The same thing. How far do I have to go? 21.
You don't have to set up empty classes to cover 0 to 10.
Say again?
You don't have to set up empty classes to cover
No,
0 to
you don't. Your classes only have to go from the lowest data point to the highest. Or they have to have a place for the lowest data point to go up to the highest data point. So I don't need to start at 0. I like it. Why did this data start at 0? Because there were people that used a whole bottle of shampoo in like a day, I guess. Less than a week, 0 weeks. Holy shit. Where's 30? So I'm going to take 21 divided by 6. So just to formalize this, class width is range divided by number of classes. Now, since this isn't a physical situation, I don't have another wall that I'm going to run into, I can change the width of my rectangle to make more numerical sense. So what is 21 divided by 6, approximately? Well, actually, it is equal to what? 3.5, yeah. Now, if I am you, I don't want to use decimals to do this. So you can pretty much always round up what you get here. The important thing is that if you end up with your rectangles not wide enough, are you going to make it all the way through your data? No. If you make them wider than they're supposed to be, then you'll make it all the way through. Everybody's going to have a home to go to. So we got to, if we get into this, you'll see what I mean by that. So I'm going to round this up to 4. So I want my width, just like on the shampoo problem, their width was 20. I want my width to be 4. Okay, so I'm going to, this is the last one we're doing today, by the way, because then we have to go on a little field trip. Maybe. Yeah, because I'm going to let you guys do this worksheet. We'll see how it happens. There are 2 main ways to set up the classes. I'm going to show you both ways. I'm going to start with the textbook way. I'm going to start with what the textbook does. I don't know why they always do this. I personally like the other way better. Doesn't mean you get bonus points if you do it the other way. You do whichever way makes more sense. So what's the lowest data point? 11. So 11. Now watch. No, I want this to really make sense. This is the textbook method. The other method's easier, I think, but it involves X and it has inequality symbols, and people freak out about that. If the classes are supposed to be 4 wide, where should the next class start? 15. Does that make sense? If it starts at 11 and it's supposed to be 4 wide, the next one should start at 15. You can't argue with that. Probably could try it. If I do this, though, why does this make no sense? Where would 15 go? In both of them? Then I would double count, and that wouldn't be good. So I have to make this 14. So that's what you have to do if you want to use the textbook method. These numbers here are called class limits.
But then theoretically, a 14.5 would have no home.
Exactly. So these built-in half up and half down decimal points. I personally don't like, but I'll show you this because it's the way the book shows you. So now you just keep adding 4 because the width is 4. So this would be 15 to 18, and then add 4, add 4, add 4, add 4, add 4, gather. Add 4, so 1, 2, 3, 4, 5. And what did I, 6. Add 4, add 4. Cool. What was the highest data point? 32. Did I stop at 32? No, of course I'm not always going to stop at the highest data point because we just rounded up for the width, didn't we? I like it. So we didn't have to have decimals involved in all these numbers too. That would be kind of disgusting. So every data point has to have a place to go. You don't have to start at 11. You could have started at 10. You don't have to stop at 32, right? We stopped at 34. But every data point has to have a place to go. Let me see. I'll show you this right now. Let me put on the side what it will look like. It's not really my way. It's the way I was taught. But I see fewer and fewer books doing it this way. I have no idea why, because it's just so much better. So my way would say this. Let me see if you guys get this. And so forth. Why is there no ambiguity here? Where's 15 go?
Those can be in the 15 to...
Yeah, why does it not go here? Because this should include the values that are less than 15, not equal to 15. The 15 would go here. Right? If my data had decimals in it, then this would cover that. Where would you put 14.8 in the first one? Where would 15.2 go in the second one? This way would suck with decimals. Oh my God. Again, you can pick whichever way you like better. I'm kind of sad that people don't like this as much just because there's an X and inequality symbols. That makes me a little sad. But if you don't choose it, I'm not going to think less of you. I'm not going to give you a lower grade, whatever. You can do either way you want to. This column is going to be the tally. How frequently does something show up in here? Every now and again I'll get a student that does this. This is not the right answer. Why is he getting all 3s? That's not right. There's not 3 data points in the world. I don't know. Right? They're not all 3. He just did 14 minus 11 is 3. That doesn't make any sense. You're going to get... How many data points are from 11 to 14? In this case, there is 3. How many data points from 15 to 18? 1, 2, 3, 4. 19 to 22? 1. 23 to 26? 2. 27 to 30?
No.
None. And then 31 to 34? 3. I like it. So this idea actually shows up in section 1.3. But I'd like to talk about it now because we're not only going to create this table. This is called, remarkably enough, this is called a frequency table. We're not only going to create the table, we're also going to make a histogram immediately after it. And that's what you do in chapter 2. Now, if I do whole numbers, there's a better way to do this to show the relative amount in every class. How would I show the relative amount in every class? Like in this class, there's 3 data points out of, how many total data points were there? If you add these up, 7, 8, 10, 13. So what was so when I say relative frequency, or the real freak, that's just another name for percentage. So what percentage of the data is in that first class? 3 out of 13. And whatever the hell that is. Maybe I'll find it. It's like 22%.
23.
20. Yeah, what'd you get exactly? 0.23?
0.2307.
23? 1? Okay, I got you. Cool. And then keep going. 4 out of 13, 1 out of 13, 2 out of 13, 0 out of 13, 3 out of 13. Make percentages out of all of them. Percentages are things that we created ourselves because it makes more sense to us to say 11% instead of 0.11. 11% means something more to us, yeah.
If it's not like signified, how far do you want us to go digit-wise? So, like,
We're going to do this, we're going to create this by hand, but I would say 3 decimal places here.
Okay.
Yeah. Let me just say this to you right now. We're going to be doing a lot of calculations, and in general, if you take everything to 4 places, because there's a situation where I'm like, take this to 4 decimal places, always. So if you just take everything to 4 decimal places, you'll be fine.
Okay.
You could add on top of this course the idea of significant digits, which in science is called significant figures. Right? So I don't know if you guys have ever hit that idea before. I'm not of that mindset. Right? Just round everything to 4 places. There's only one thing that won't go to 4 places, and that's just because there's a chart we use that only goes out to the 2nd decimal place. That's the only thing. But since we're going to draw this by hand, going out a crazy amount of places doesn't really make sense. Right? What do you guys get for 4 out of 13? 30.8?
I'm rounding. That was that.
Yeah. So it was 0.307 something, maybe? Yeah, beautiful. Truly round. Don't just cut. I'm kind of depressed about how few people seem to know how to round. I mean, this is something you should all just know. If the next number's a 5 or bigger, you make that number go up. I mean, so just know this. 1 out of 13. That's like 0.076? 77? And then 2 out of 13, that'd be 0.154? 0 out of 13, yay! And then 3 out of 13 we did already. Lock it. 23.1% again at the bottom. So we're going to construct a picture that's going to look exactly like the picture did for the shampoo. One little difference that I almost always make you do this instead is I'm going to use relative frequency for the y-axis. Because again, percentages mean something more to us. They give us a better picture of the relative amount. So there's another level to how bad this is compared to this. When I make the picture, what would a gap mean? If there was a gap between 2 bars, like on the shampoo picture, what does that mean? There's nothing there. But look how these numbers have gaps built in already. So I cannot use these numbers to construct my scale. I love you guys. You guys are like, what the shit? But if I try to make a picture like this, and I put 11, 14, then I'm going to have 15, and this is going to be empty. That's dishonest. There's no empty classes. So the next kind of level of weirdness with this method is, you said it earlier, so yeah. In order for these to not have a gap, I've got to say what this really does is it goes from 10.5 to 14.5. So where would this go from? See how it went down by half, up by half? So this would go from 14.5 to 18.5. See how now there's not going to be a gap? They're going to run into each other? No gap. So what I always think of, these numbers here, like I said earlier, are the limits. So there's a limit to me. I stop right here. This is where Jeff stops. Jeff stops here. Then we have boundaries that, if I don't know you that well, do not get closer to me than my boundary. Are you with me? This is where Jeff stops, but if you're right here, you're in my boundary. Get the hell away from me, right? So boundaries are that little area around us that we're like, get out my grill if you're too close. And this is where we physically are. I don't know if that makes sense. That's how I always looked at this. I use this, but to make sense out of this, that's how I made sense out of this. Maybe. So if I do it the book way, my scale is going to look like this. 10.5. Then you just keep adding 4, of course, because the width is 4. Okay. I think everybody knows there's a quiz coming. Okay. Now, if you did it with the inequality way, here's what the scale would look like. Right? Just these numbers. There's no, the limit is the boundary in this case. This is somebody that has no boundary. They're like, you can be right up on them like, hey man, how you doing? I'm all right, how you doing? So this is much simpler. I am sort of trying to push you in this direction, but you can do it this way. There's nothing really wrong with this. It's just got extra stuff to be careful about. That's all. So whichever way you do it, you've got to put labels on your axes. I don't think, did I give this a meaning? No. Let me give this a meaning. Let's say these are ages of people at a bus stop. So we can have some scale, some meaning to this. Ages. And then I want to make, so officially this is a relative frequency table. So now we're going to make a relative frequency histogram. So in the book, in the homework, if they ask you to make a frequency histogram, you would use these numbers. So we're going to use these numbers. What kind of scale do I need, do you think? How far up do you have to go for these percentages? I got to go up to here, a little past this. So what kind of scale I don't want to use 1. What kind of scale might you want to use? It's up to you. So you can go by 3, 6, 9, 12. So what kind of scale do you want to use to get up to here?
Maybe 5?
Sure, let's do 5. 5, 10, 15, 20, 25, 30, 35. I like it. And then you put a little label, real freak. Well, you know, this isn't difficult. It's just different than stuff you've done before. How tall would I make that first bar? So what's the first bar? What class is it going to be? From 10.5 to 14.5. And how tall does it have to be? About 23. All right, so you're going to go, wee-haw, all right there. And then keep going. How tall is the next bar? Almost 31. Just a little over 30. Next bar, almost 8, so about right there maybe. And then 15, just a little over 15. 8. And then nothing, and then 23 again. So it's going to be the same height as the first dude. Kabam. There it is. Cool. Again, not difficult, just different than what you're used to. Would you say that this looks what's called, You guys, so if everybody did really bad on a test, what do you call it when the teacher kind of changes the grades? Curve. Where does that come from, that idea of curve? The bell curve, 11, the normal curve. The bell curve, have you guys heard of the bell curve? So theoretically, there should be a lot of people scoring right near the average and then not many people out there. Also, sort of like what else follows this curve would be something like heights of people. Most people should be close to the average height. These people out here would be what we call unusual or unexpected. If I saw somebody who was 3'9", would you not sort of do like a double take or something? You don't see that every day. Or when I saw Manute Bol, anybody know Manute Bol? Anybody know that name? It's like 7'7". He was coming off a Southwest flight, and he saw a little group of people, and he saw his head, because 7'7". So that was unusual. He's way the shit out there. So one thing that a bell curve defines is what is usual, what's expected. Not everything follows a normal curve. This certainly obviously does not. It's got to start low, go high, and then go low again. That don't do that shit. So that's not normally distributed, which is fine. It just isn't normal. So what I want you to do on the other side of this shampoo sheet is your histogram problem. Right? Let me do this. Who needs to borrow a calculator? Let me show you how to sort data in a calculator. I'll do that now. What I need you to do, if you need a calculator, is bring up an ID. I've learned the hard way. I can't be so trusting. Or a phone, sure. Anything I can sell on eBay. Make sure that, no, you're fine. Make sure you got battery before you get too far away.
Sit for a moment.
Fine. Just don't feed. Sure. Make sure you got battery before you get too far. Okay. Sorry. All right, don't get too far. Try that one. Might as well just keep using this. Yeah, okay. This will be. Oh yeah, it's the one that needs to. So I want to show you, so this is getting into the region of the calculator where we're going to live for most of the time. And what button do you think takes us to where we're going to live? No way. So there's a stat button, right, there's a math button right there. Now that's like, okay. So if you've never seen this kind of calculator before, now I know I'm not the normal kid. When I was a little kid, like the tax consultant would come to our house, and I would want to play with their calculator. That was me. So it was kind of like in the cards for young Jeff. I was like, oh, wow, look at this shit. But please your God, even if you're not like me at all, you still should be like, let me hit that frickin' math button and see what the shit. So that very first, real quick, this has nothing to do with this problem yet, but I just want to show you some of the stuff. What do you think the very first thing does? Now watch, so it converts to a fraction. So if you did like 0.2458, math, convert to fraction, it'll give you a reduced fraction for that, right? Or if you did this 7/8 times 5/9 divided by 4/5, and you get that disgusting thing, math, fraction, bam. Don't you wish you knew about that, like 5 semesters ago, whatever, maybe 3, 2. Anyway, just to show you, that's kind of nifty. So there's a lot of shit under math. Look at all that shit. Anyway, so hit the stat button. So the worst part of statistics, and this is just period true no matter what your opinion is data entry. That just sucks. And that's why those jobs, work at home for whatever amount of money, is data entry. Just get all this data in there so we can do shit to it. What I try to do is, there's going to be several times in the class where you're going to do stuff on the calculator and then you're going to come up and show me what you've got. And I will try to help you if things are off, because I can quickly see what's kind of like not right in the lists. So here's where we go. See where it says edit? Calc is where we can do stuff to data once we edit a list, get our data in. So everybody go to edit, hit enter. Please, dear God, when we have a technology day like this right now, immediately let me know if something's weird. For example, does everybody have a list 1, a list 2, a list 3? All right. If ever...
What did we click?
Oh, sorry. So again, go stat, edit. Just hit enter, or you can hit the number 1. I got data in there, of course, from the 4-week intercession course I did. So first thing I want to do is clear it. You guys have data in there? If you borrowed it from me, you probably do. Don't hit delete, because look, my list 1 is gone. Shit. So to get the list back, you go to stat, setup editor. Now, while I'm thinking about it, just to remind you guys, do you remember the website? You know, the website? I don't use Canvas. It's bullshit. I don't like it too bad. On the website, I've got a little calculator guide. You might want to print that shit out for yourself. You can't use it on a quiz or a test, but you should have it sitting next to you for homework, right? And it talks, everything I'm talking about right now is on there. You with me? Okay, I like it. So now if I go back in, my list is back. Stat, edit, my lists are back. To clear it, I go up to the list and hit clear. Enter. Go up to list 2, clear. Enter. You guys with me? Clear. Enter. All right, we don't need all that shit. We just need one list field. Okay. Like it. Now, let's all take a minute and just put this data in. Just put all this data, come to me data. There it is. Just put all that data into list 1. Don't do list 1, list 2. This is all one set of data, right? Father's heights. So put all of it in list 1. Shit, where am I? Over there. Yay. Okay, that's good. All right, so here's clickety clack. So we got their data in there, guys. So here's what you do to sort it. You might have noticed this when we hit the stat button in the first place. Hit the stat button again. Why are there 2 sort options? What do they mean?
High to low, low to high.
Yeah, sort ascending, sort descending. So let's sort ascending from low to high. Notice how, so there's sort ascending. Hit enter. So are you with me right now? Hit enter so it should look like that. And you see the parentheses is sort of like in algebra. It wants an input. It's like sort what? What the shit you want me to sort. So if you just hit enter now, it's going to be like, what the hell? When you get a go-to option on the syntax error, it's not draggable, but go to, and it puts the cursor on the problem. You just forgot to tell it what to sort. So look where your lists are. Above 1 is list 1. Above 2 is list 2. So you would hit second 1 to get list 1. Enter. Now it's kind of anticlimactic. It's like, done. It's kind of like, all right. Then I got to go back in. Stat, edit, and now it should be in order. Right? Costs enough money, so it shouldn't be that amazing. Right? $100 should be able to do that shit. Now just keep going. Now you can do that problem a lot easier. Right? It's going to help you when you get to this step, right? Set your classes up, and then you can count much easier now that they're in order. Go for it. finish that stuff out.